हेलो। हेलो एवरीवन। एक मिनट रुकिएगा, थोड़ा सा मैं लाइव हो जाता हूँ अनअकैडमी एप्लीकेशंस पे भी। वेट अ बिट। थोड़ा सा होल्ड करेंगे, है ना। अनअकैडमी एप्लीकेशन में भी लाइव हो रहे हैं, तो मैं आप सब लोगों को रिक्वेस्ट करूंगा, पीछे जो क्वेश्चन दिख रहा है ना उसको आप सॉल्व करने की कोशिश जरूर करो। इतना से मैं अनअकैडमी में भी लाइव हो जाता हूँ। आप लोग फटाफट ट्राई करो, जो भी बच्चे मुझे यूट्यूब में फॉलो कर रहे हैं। हेलो। 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 एक मिनट होल्ड करेंगे यार, है ना, अनअकैडमी में लाइव हो नहीं पा रहा है। एक फाइनल ट्राई देते हैं, अदरवाइज यहीं स्टार्ट करेंगे क्लास फिर। हेलो एवरीवन, वेलकम टू अनअकैडमी। एक्सट्रीमली सॉरी, मैं अनअकैडमी एप्लीकेशन में भी लाइव होने की कोशिश कर रहा था बट वहाँ लाइव नहीं हो पाया। एनीवेज, मैं यूट्यूब में कंटिन्यू करता हूँ, तो ये क्लास एक्सक्लूसिवली केवल यूट्यूब पे चल रही है। लास्ट क्लास में बेसिकली वी हैड टॉक्ड अबाउट द इन्वर्टिंग एम्पलीफायर एंड द काइंड ऑफ इन्वर्टिंग एम्पलीफायर व्हिच वी हैड टेकन इन द लास्ट क्लास इज बीन आइडियल इन नेचर. Virtually speaking, input impedance, output impedance, AOL, those all values were taken in ideal in nature. Like मैंने AOL को infinity लिया था, इनपुट इंपेडेंस आर इन को इन्फिनिटी लिया था, आउटपुट इंपेडेंस आर नॉट को जीरो लिया था. फिर थोड़ा सा मैंने प्रैक्टिकल एंगल भी यहाँ कॉन्कर किया, जहां मैंने AOL की फाइनाइट वैल्यू ली थी और AOL की फाइनाइट वैल्यू का यूज करते हुए हमने इन्वर्टिंग, नॉन इन्वर्टिंग अलग अलग एम्पलीफायर्स का टोटल क्लोज लूप गेन निकाला. इस तरीके के क्वेश्चंस बहुत डिफिकल्ट नहीं होने वाले. लगभग लगभग सर्किट लेवल पे आप इस क्वेश्चंस को आराम से खत्म कर लोगे. यही मैं समझाने की कोशिश कर रहा हूं कि आप आंख बंद करके ना पहुंचे गेट में. अगर आपको थोड़ा भी एक क्लियर कट आइडिया है कि यार ऑपरेशनल एम्पलीफायर के अंदर इस तरीके से कुछ रिप्लेसमेंट होता है, तो सर्किट का स्ट्रक्चर डेफिनेटली गेट में अलग होगा. जिस तरीके के क्वेश्चंस पहले पूछ लिए गए हैं, पूरे चांसेस है कि उस तरीके के क्वेश्चंस आपसे आगे नहीं पूछे जाएंगे. तो वो कुछ का कुछ ऑपरेशनल एम्पलीफायर का सर्किट बना लेंगे और AOL की वैल्यू हो सकता है 100 दे दें, 200 दे दें, नॉन इनफाइनाइट दे दें, फाइनाइट दे दें. तो उस समय करना क्या होगा, आप केवल खोजें कि आपका V प्लस और V माइनस कहाँ है, उनके बीच का पोटेंशियल डिफरेंस VID ले. ध्यान रखेंगे पोलैरिटी पॉजिटिव होगा नॉन इन्वर्टिंग टर्मिनल की साइड और निगेटिव होगा इन्वर्टिंग टर्मिनल की साइड. उस VID को अब AOL का गेन दे दें. AOL अगर प्रॉब्लम में 100 दिया है तो 100 ले लें, 20 दिया है तो 20 ले लें और सीधे आउटपुट में रिफ्लेक्ट कर दें. और ये सर्किट बन जाना है एक डिपेंडेंट वोल्टेज सोर्स का. इस तरीके की प्रॉब्लम पता नहीं आपने ना जाने कितने किए होंगे नेटवर्क में. आसानी से नेटवर्क से ये प्रॉब्लम बन जाना है. ठीक है, इसी सीक्वेंस में एक क्वेश्चन आज की क्लास का एजेंडा होने वाला है. गेट इलेक्ट्रॉनिक्स 2015 का क्वेश्चन है. अज्यूमिंग दैट द ऑपरेशनल एम्पलीफायर इन द सर्किट बिलो इज आइडियल, द आउटपुट वोल्टेज V नॉट इज. देखिए, इस प्रॉब्लम को देख के वर्चुअल ग्राउंड थ्योरी में थोड़ा सा शंका होता है. अगर वो वाला पार्ट अगर आप जीत जाते हैं तो खत्म हो गया ये प्रॉब्लम. ये देखें, बताएं इसका आंसर क्या आने वाला है. आई वुड लाइक टू हैव द इनपुट फ्रॉम ईच वन ऑफ यू. टेल मी व्हाट इज सपोज्ड टू बी द आंसर फॉर दिस गिवन क्वेश्चन. गुड मॉर्निंग डियर. यस, देखिए सबसे पहली बात तो यहाँ वर्चुअल ग्राउंड थ्योरी ट्रू नहीं होगा. क्यों नहीं होगा? वर्चुअल ग्राउंड थ्योरी केवल तब ट्रू होता है जब आउटपुट सैचुरेट ना हो. बट यहाँ फिजिकली आपने इस टर्मिनल और इस टर्मिनल को 0 और 1 वोल्ट से कनेक्ट करके रखा हुआ है. और अगर इनपुट के दो टर्मिनल के बीच में अगर थोड़ा भी वोल्टेज डिफरेंस हुआ, समझिए क्या बोल रहा हूं मैं, अगर इनपुट के इन दो टर्मिनल के बीच में थोड़ा सा भी वोल्टेज डिफरेंस हुआ तो आउटपुट में जो गेन मिलने वाला है वो मिलने वाला है AOL का, आइडियली स्पीकिंग इनफाइनाइट का. अगर थोड़ा भी पोटेंशियल डिफरेंस इसके बीच में रहा तो आउटपुट जो है वो सैचुरेट कर जाएगा. समझ में आ रहा है क्या बोल रहा हूं मैं? अगर V प्लस माइनस V माइनस अगर ये वैल्यू जीरो नहीं रही, नॉन जीरो रही, तो V प्लस और V माइनस को जो गेन मिलता है वो AOL का मिलता है, थ्योरेटिकली स्पीकिंग जो इनफाइनाइट होता है. तो इसका मतलब ये छोटी सी छोटी वैल्यू को अगर आप इन्फिनिटी से मल्टीप्लाई करेंगे तो ऑब्वियस ही बात है ये वैल्यू इन्फिनिटी की तरफ जाने की कोशिश करेगा. या तो प्लस हो सकता है. प्लस कब होगा? जब V प्लस की वैल्यू V माइनस से बड़ी हो तो ये प्लस होगा. जब V प्लस की वैल्यू V माइनस से बड़ी हो तब ये प्लस इन्फिनिटी होगा आउटपुट वोल्टेज. एंड सिमिलरली जब V प्लस की वैल्यू V माइनस से छोटी हो तो ये माइनस इन्फिनिटी जाने की कोशिश करेगा. लेकिन प्रैक्टिकली क्या प्लस इन्फिनिटी माइनस इन्फिनिटी जा सकता है? कतई नहीं जा सकता, क्योंकि क्लियरली आपको प्रॉब्लम में सप्लाई वोल्टेजेस दिए हुए हैं कि आपका आउटपुट कभी भी +12 बियॉन्ड नहीं जाएगा, -12 बियॉन्ड नहीं जाएगा. आप प्रॉब्लम को रीड करें, पहले ये देखें कि V प्लस और V माइनस में से बड़ा है कौन. आप अच्छे से देखेंगे तो V प्लस +1 वोल्ट पे कनेक्टेड है, V माइनस 0 वोल्ट पे कनेक्टेड है. तो जो सिचुएशन बन रही है वो बन रही है V प्लस इज बीन ग्रेटर देन V माइनस. इस कंडीशन में आउटपुट बहुत लार्ज पॉजिटिव वैल्यू पे सैचुरेट करने की कोशिश करेगा, बट ये 12 से ऊपर नहीं जा सकता. एंड हेंस द आंसर इज सपोज्ड टू बी ऑफ +12 वोल्ट. Hence the answer is supposed to be of +12 volt. Even what I feel few more important questions can get framed within this same question as well. आपसे पूछा जा सकता है what had been the amount of current which will flow through this terminal what had been the amount of current which will flow through this terminal. Let's take this has been I2, let's take this has been I1. देखिए जब तक आपको ऑपरेशनल एम्पलीफायर का आउटपुट वोल्टेज क्लियर नहीं है, आप I2 और I1 निकालना कभी ट्राई ना करें, क्योंकि ऑपरेशनल एम्पलीफायर का आउटपुट वोल्टेज 12 के अंदर होता तो 11-10 बिल्कुल परमिसिबल वोल्टेज है, और उसके हिसाब से इस दो टर्मिनल के बीच में पोटेंशियल डिफरेंस बनता और उसके हिसाब से ये करंट निकलता। तो देखो अभी भी करंट निकालने का तरीका वही है जो नेटवर्क में यूज किया है। रेजिस्टेंस के अक्रॉस जब तक आपको पोटेंशियल डिफरेंस क्लियर ना हो, करंट निकालने की चेष्टा ना करें। हैज इट बीन क्लियर? Did you really understood what exactly I wanted to communicate? Whenever you have been seeking for the current across any kind of resistance, until and unless the potential difference between that resistances are not been known, you won't be able to get the exact amount of current which has been passing through the given resistance. So that is what I am saying. If you talk about the amount of current this 2 kilo ohms is going to carry, until and unless the potential across this and this terminal is not known, you won't be able to know that fact. Agreed what I'm saying? Because whatever the current might be flowing through this terminal or this loop, all the way making a closed path and coming back through this. So obviously this current is not going to contribute any amount of current through this 2 kilo ohm as it had been happening earlier. Because whatever the amount of current was coming through the source all the way, those current only becomes a feedback current. But this is not the situation now. Anyways, may I know what is going to be the current across this terminal? See, here it has been physically grounded. And keep in mind, nobody should use the virtual ground or virtual short theory. This 1 volt will not reflect over here because it has been physically grounded. So here it has been 0, here it has been 0. 0 minus 0, there had not been any potential difference between this resistance, and the yes result supposed to be of 0 milliamperes current we get. 0 milliampere current we get. Whereas if we talk about the I2, see, physically this terminal is been kept at 0 volt. Yes, sir. This voltage is being 12. So here comes the higher potential to lower potential. There would be a flow of current that would be equals to of difference between their voltage divided by the resistance. And that is supposed to be of 12 minus of 0, that is been 12 divided by of 2. And here the amount of current which we get, it is supposed to be of 6 milliampere. It is supposed to be of 6 milliampere. Has it been clear to all of us? Another very well designed problem we had, let me see where it had exactly been. I will take that question as well. Utterly well designed question. If I won't be able to find that question, I will design by myself, but let me see if it has been there somewhere. Perfect. Here comes the question. This is from page number 20. Here comes the question. This has been a problem from gate instrumentation year of 2007. Although only one parameter they had asked to calculate the output voltage, but along with this output voltage, we will try to find few more number of important electrical parameters across this operational amplifier. So have a look of this given question, and we will try to analyze the different aspects of this given circuit. We will try to analyze the different aspects of this given circuit. So here comes a question. 3 different parameters I need to calculate. The first question has been, you need to calculate V0. You need to calculate V0. Once you are done with the V0, you need to calculate voltage across inverting terminal, and let's take this has been a V minus. You also have to calculate the value of V minus. Third, you have to calculate the amount of current which has been flowing across 1 kilo. Let's take this current has been taken as I1. This current has been taken as I1. I need to calculate this 3 different important electrical parameter taking the reference of this standard operational amplifier. this standard operational amplifier. Tell me what is supposed to be of V naught. What is supposed to be of V naught? Once you're done with the V naught, you also have to calculate the value of V minus, and once you're done with that, you also have to calculate the value of I1 as well. I1 as well. Read the problem carefully and tell me what is supposed to be the best most answer which we have for this given question. Read the problem carefully and tell me what is supposed to be the best most answer. Ravi, perfect, perfect. Anyways, we will use the gain which has been offered by the inverting amplifier. May I know the closed loop gain which has been offered by the inverting amplifier is we had already seen, and that is nothing but minus RF by R1. See, input is already known to me, and that is nothing but 10. The feedback resistance is been at -2. R1 जो है वो 1 किलो दिया हुआ है, 10 से मल्टीप्लाई करें, आउटपुट जो है वो -20 वोल्ट की तरफ जाने की कोशिश करेगा, -20 वोल्ट जाने की कोशिश करेगा. Has it been clear to all of us? Yeah. Yeah. लेकिन आपने पहले भी देख रखा है कि आउटपुट कैन नॉट गो बियॉन्ड +20 और -20. And as it has been the case, obviously the V naught will stuck at -15 only. देखिए, the next doubt which comes in our mind, so what about the voltage at inverting terminal? Would it be 0? No. If this will be taken as 0, keep in mind, once you'll apply the KCL, no, the output will be stackled at -20 only. तो आपने ये चीज ध्यान दिया या नहीं दिया? जब आपने वर्चुअल ग्राउंड थ्योरी लिया है, if you had taken this voltage as 0, the output will find as -20. आउटपुट कितना मिलने वाला? -20. You can apply that. 0 minus of 10 divided by 1 kilo, 0 minus of V naught divided by 2 kilo, and there the output voltage will be -20. But the output voltage is no more -20. What does it actually mean of it? अगर आप इस KCL में 0 लेके आउटपुट कैलकुलेट कर रहे हैं, you get the output voltage as -20. But now the output voltage is no more -20. In that case, the voltage across this terminal is no more 0. Virtually speaking, virtual ground theory is again been smashed. तो वर्चुअल ग्राउंड थ्योरी कब तक ट्रू होगा? दिस वुड बी ट्रू until and unless the output does not saturate. It does not goes beyond +15 or -15. चाहे वो आप ओपन सर्किट भी ले लो, when you take open circuit then also, अगर ये कंडीशन मीट होती है तो ऑब्वियस सी बात है, ये कर सकते हैं. आगे बात समझ में? till this point each and everything must be clear to all of us. तो मुझे ये लगता है कि definitely most of the student what they would do, see, Ananta, Ravi, have a look on this given question. Rather giving V naught, try to understand what exactly I wanted to communicate. Rather giving V naught, if straight away I might have given, find the value of V minus for the 1 mark. Many of the students will write 0 and they'll go ahead. Why you have been able to analyze this problem? Because first I had asked you to calculate the V naught, and you got to know that the V naught is not, getting saturated. So probably this problem has been bit fishy. समझ में आ रहा है क्या बोल रहा हूं मैं? अनंता भाई, ये प्रॉब्लम में अगर V नॉट ना देके सीधे V माइनस पूछता तो प्रोबेबली आप शायद इस क्वेश्चन का आंसर गलत करते. बोलते सर आउटपुट तो सैचुरेट होगा, ठीक है ना सर, ये 0 है तो ये भी 0 होगा. सो माइंड दिस प्रॉब्लम वेरी वेल. In future they can ask this kind of question. If they will ask the value of V naught, it has been a comparatively easier question. If they will ask the value of V minus straight away, it will be a bit tricky question. If they ask the value of I1, it is going to be of difficult most question. Why? Because what the people will do, they will take this as a 0, 10 minus 0 divided by 1 kilo. They will try to calculate the current. So I would request to each one of the student, कभी भी ऑपरेशनल एम्पलीफायर का अगर कोई भी प्रॉब्लम आप लोगों के सामने आता है, so have a watch on two important point. First, whether the supply voltages are being given. जब भी किसी भी ऑपरेशनल एम्पलीफायर में सप्लाई वोल्टेज दिए हुए हैं, there are been chances approximately 60 to 70% कि वो ऑपरेशनल एम्पलीफायर सैचुरेट हो रहा है। सैचुरेट हो जाने के बाद वर्चुअल ग्राउंड थ्योरी ये सब कंसेप्ट्स ट्रू नहीं होंगे। द सेकंड इंपॉर्टेंट पॉइंट, द सेकंड इंपॉर्टेंट पॉइंट, साथ में ये भी देख लेना कि कहीं सप्लाई वोल्टेजेस की जगह में कहीं ऐसे कैलकुलेशंस तो नहीं करा रहा है कि एकदम स्टैंडर्ड सर्किट दे दिया है। आई हैड सीन मेनी अदर टाइम्स straight away standard circuit is being given just to make you guys confused, because once you meet with a standard circuit now, आप लोगों के दिमाग के जो एंटीनास हैं they get stand up and you'll say sir the gain will be offered by the system has been minus RF by R1 and straight away I got the answer. Deliberately they had designed the problem in such that had the relevancy with a standard problem, and as it has a relevancy with a standard problem, definitely there are the chances you'll do the straight calculation and you'll commit the mistake as well. You'll commit the mistake as well. So what I'm saying, I will take the reference of V naught as minus 15 and I'll recalculate the value of V minus. It is no more 0. So here comes V minus. Yes, there are been the two active branches through which there would be a translation of current. See, KCL talks about net incomer and outgoer current at any node is being 0. Although this has also been a conducting path, but being ideal operational amplifier, inverting terminal is no more sinking any current. So obviously only two active paths through which the current transfer or the translation will take place, and that is going to be this path and that is going to be this path. I had taken this as a principal node. I would presume all of the current is been leaving from this side. So here it becomes V minus minus of 10 divided by of 1 kilo. V minus minus of V naught. V naught is already been known to me, and that is been minus minus becomes plus 2 kilo and is equals to 0. So probably you guys had already calculated it. May I know what is supposed to be its answer over here? May I know what is supposed to be its answer over here? Tell me. So we will take its LCM. 2 kilo goes towards right hand side. It smashes with 0, and here it becomes 2 times of V minus minus of 20 minus of 20. Then comes V plus, sorry, V minus plus of 15 is equals to 0. So here it becomes 3 times of V minus. Yes, 3 times of V minus, and this becomes minus 20 plus 15, that is been minus of 5. Minus of 5 goes to the right hand side, and here V minus is equals to 5 by 3. Virtually speaking, this potential at inverting terminal satisfies the requirement of KCL, which will create the output as minus 15 volt. Which will create the output as minus 15 volt. So may I know what is supposed to be of V minus? V minus is going to be of this. Now, even if we'll talk about the direction of the flow of current, always the direction of flow of current would be from higher electric potential to the lower electric potential. So obviously here the worth has been 10, here the worth has been 5 by 3. 5 by 3 is quite smaller in terms of 10. So the flow of current would be in the direction of I1. What does it actually mean of it? That means the polarity is supposed to be of positive. अब ध्यान देना, polarity अगर आप positive ले लेते हैं, just take the magnitudal difference. Don't think sir 5 by 3 से 10 घटेगा, जो भी घटेगा you take mod of it, because the direction is clearly known to me. So here 10 minus of 5 by 3, and towards denominator side it is merely 1 kilo. Anyways, the kilo will contribute millis. Good morning dear, good morning. And we get the answer out of it. We get the answer out of it. Has it been clear to till this point? अनंता, मैं इंग्लिश बोल रहा हूँ तो आपको कोई दिक्कत तो नहीं हो रही है ना? क्योंकि मैं दोनों यूज कर रहा हूँ. I am trying to use the English and Hindi both, because Ravi Teja has also been there and Swami has also been there. They have been more comfortable in English, so that is why I had been trying to communicate in both Hindi and English both. So till this point, each and everything has been clear or not? I would like to know from each one of you. Swami, this has been a well-designed question, and you can expect this kind of the questions in near future. Even in PSUs also you can have this kind of questions. Ravi and Swami, have you seen this kind of the problem earlier? Because this is a very well designed question. This is a very well designed question. अनंता, आपने इससे पहले इस तरीके के क्वेश्चंस किए हैं क्या? Really, they have been very well designed question. A very well designed question. अनंता, हो जाएंगे इस तरीके के क्वेश्चन? ये भी बताएं मेरे को. I would like to know this fact as well. So okay, about engineer, have a look on this question. I had a standard inverting amplifier. Taking the reference of this standard inverting amplifier, I wanted to calculate these three electrical important parameters. First, I wanted to नहीं आपने देखा है लेकिन बनता था या नहीं बनता है सर आई हैव डन दिस ग्रेट डियर ग्रेट so here I wanted to calculate its V naught, V minus and I plus. The catch behind this problem is been deliberately I have brought the power supplies and I had the input in such the output is going to get saturated. See, when I had applied minus RF by R1 into input 10, the output has been going beyond minus 15. And as the output is going beyond minus 15, definitely the output would be saturated at minus 15 itself. Yes, sir. Here it comes to minus 15. So first mistake you guys may do, you can simply apply minus RF by R1 into Vin, and you may also write the output as a minus 20, but whereas the output has been minus 20. Take. Now, once approximately in 2015 or year of 2016, they had given a standard circuit. They had given the supply voltages and they have asked the voltage across this terminal. Most of the student had done the mistake. What they would do? They would think, sir, forget about saturation and all. But here at least the virtual ground theory would be true. No, my dear friend. Until and unless the output is non-been saturated, जब तक ये saturate होगा, तब तक ये use नहीं होगा और ये जब saturate होता है, we can't use it. So as you can see very well, the operational amplifier has been saturated at minus 15. So once you'll apply the KCL at this terminal, now the voltage has been something very else and we get the value of V minus as 5 by 3. So keep in mind, this is no more 0. Namaste dear. ठीक तस्लीम एक बार आप ये भी देख लें कि दिस काइंड ऑफ द क्वेश्चंस आर बीन रिपीटेडली आस्क्ड इन डिफरेंट गेट एग्जामिनेशंस क्योंकि वर्चुअल ग्राउंड थ्योरी वर्चुअल शॉर्ट थ्योरी पे क्वेश्चंस तो पता नहीं कितने भर के आए हुए हैं मैं सामने अपना वर्क बुक रखा हुआ हूं आइडियल ऑपरेशनल एम्पलीफायर पे ज्यादा तो नहीं बोल रहा हूं कम से कम 250 क्वेश्चंस ऑलरेडी आ चुके हैं सो नाउ देयर वे ऑफ आस्किंग द क्वेश्चन इज बीन बिट चेंज्ड deliberately they bring the supply voltages with the operational amplifier कभी भी operational amplifier के साथ supply voltages अगर दिए हुए हैं there are been the chances deliberately they will force this operational amplifier to operate in saturation region and यहाँ भी यही हुआ है 10 वोल्ट के कारण आउटपुट जो है वो सैचुरेट हो रहा है तो आउटपुट -20 ना होके -15 है अब वो अगला क्वेश्चन पूछ सकते हैं कि V माइनस पे वोल्टेज कितना होगा मेरे भाई V माइनस पे जो वोल्टेज वही होगा जो V नॉट डेवलप करेगा अर्लियर V नॉट इज बीन -20 बट इट इज नॉट नो मोर बी -20 ठीक ठीक है तो इस तरीके से आप लोगों को करना था ये so till this point I don't find any of the students would have any kind of doubt now agreed चलिए एक आध और अच्छे क्वेश्चंस लेते हैं let me take few more number of better questions as well so here comes the question number 21 pages 21 again a well designed question read the problem carefully and tell me what is supposed to be the output voltage for this given circuit and that had been the question read the problem carefully and tell me what is supposed to be the output for this ऑपएम का वी सेट आइडियली स्पीकिंग देखो दो अलग अलग तरीके से आइडियल कंडीशंस ले सकते हैं सैचुरेशन की दृष्टि से in terms of saturation the value of plus minus V set must be infinity but in terms of power supply how much the op-amp power supply has been required to operate the operational amplifier in the desired way it is must be 0 so nobody should say what must be the ideal value of plus minus V set in terms of power supply requirement it has to be 0 in terms of saturation voltages I want a situation where the closed loop gain must be a linear in nature either you go for the very large value of input voltage whether you go towards a very small voltage yes Ananta has it been clear what I'm saying so kai books mein likha hua hota hai ideally V set must be this and this but I don't feel there must be any talk over the ideal value of saturation voltages Tell me what is supposed to be the best most answer which we get for this given question. I would like to have the input from each one of you. See, there have been the varieties of the answers that started coming. About engineer had the output as a 0.5 and AD had the output as a -1 volt. Anyways, read this problem carefully and then only you have to give me the best most answer. First and foremost answer for point. See, 2 volt, the part of 2 volt is going to get connected to this point, and now this point is going to get the gain and it is getting reciprocated at the output side. My dear friend, one of the important thing which you had to analyze at this point, एक पॉजिटिव इनपुट वोल्टेज इन्वर्टिंग एम्पलीफायर में लग रहा है, डेफिनेटली आउटपुट इज सपोज टू बी नेगेटिव. तो जिसका भी आंसर पॉजिटिव आ रहा है, कम से कम आप ये पार्ट तो रूल आउट करें. आंसर इज सपोज टू बी ऑफ माइनस एट एनी कॉस्ट. एट एनी कॉस्ट. The next important point, many of the students, what they do, what they will say, 20 kilo and 20 kilo, it has been in series. So the part of 2 volt which will get dropped across this terminal is supposed to be from voltage division rule, 20 divided by 20 plus 20, that has been 1 upon 2 into 2, and that is supposed to be of 1 volt. That is supposed to be of 1 volt. And now what they would do, they would take the next block, and 1 volt they would treat as an input to a standard inverting amplifier, and they will give you the gain of minus RF by R1, and they may also write this as minus RF is nothing but 20 kilo, R1 is nothing but 10 kilo, and they will apply the input as this. Many of the student also gets the answer as minus 2 volt, which is utterly wrong. Which is utterly wrong. Has it been a correct approach or somewhere mistake had been committed? ये बिल्कुल गलत approach है. क्यों गलत approach है? Have a look on that as well. See, how did you take that the 20 kilo and 20 kilo is in series and we will be using a voltage divisor at that point? My dear friend, whatever the current had been coming from top to bottom, it will split in a two part. क्यों? यहाँ इनपुट इंपिडेंस इनफाइनाइट नहीं है. अगर ये आगे जाके यहां से कनेक्टेड होता, समझो यहां से कनेक्टेड होता, तो यहाँ नॉन इन्वर्टिंग के अक्रॉस कोई करंट सिंक कर नहीं सकता. And as it is not been allowed to sink any amount of current, definitely I could have taken the all of the current which has been coming from a top limb will go towards the bottom limb. But here what happens, if you'll focus over the input impedance from this point, from a inverting amplifier, the input impedance is very same as a 10 kilo. So जो करंट ऊपर से आ रहा है उसका मेजर पार्ट जो है वो यहां से जाएगा और बचा हुआ पार्ट यहां से जाएगा. Why I am saying major part? Because this path is less resistive as 10 kilo and this path is a higher resistive as a 20 kilo. So straight away nobody should use. What I am saying, straight away nobody should use the voltage divisor rule over here. Nobody. Nobody means nobody. So what must be the approach, sir? What must have been the approach in that case? There could have been the two different approach to solve this problem out. Say 20 kilo and effective input impedance is nothing but the 10 kilo. So you can calculate the voltage across this terminal, and that becomes from the voltage divisor rule 20 and 10 they would come in parallel. Are you been clear about it? Are you been clear about it? Effectively यहाँ 20 और effectively यहाँ 10 है. So if you write this as R, so here it becomes R plus 20 into 2 volt. You will get to know the voltage across this terminal. और जब ये voltage निकल जाएगा उसके बाद में पूरा का पूरा calculation कर लो. That's been the first way. Or the simplest way is applying the node. Forget about each and every aspects of this problem. Just focus over the node and try to get what is supposed to be the best most answer which we have for this given question. Let's see what we will do over here. See, we will apply the node over here. Let's take the voltage is not been known and it has been taken as Vx. Obviously, non-inverting terminal is not going to sink any amount of current, and as there had not been any flow of current across the resistance, whatever the voltage we had at this node we'll be having at this node and this node. 0 goes here, here and here. So here it becomes 0 volt. Here it becomes 0 volt. We'll apply the node over here. If you want, we can apply the node over here as well. It's been completely up to you. So here it goes. Vx minus 2 divided by of 20 Vx minus 0 divided by of 20, then comes Vx minus 0 divided by of 10. Altogether it has been 0. Altogether it has been 0. Has it been clear to all of us? तो यहां से आपके Vx की वैल्यू निकलेगी. You will be getting the value of Vx over here. Yes. Vx की value you will be getting out of it. And then you will be applying the node at this point. And here it becomes 0. Vx value has already been known. 10 kilo. 0 minus of V naught divided by 10 kilo is already been known. And you are done with that. You are done with that. एक तरीका और भी है. ध्यान देना. And that matter is nothing but Thevenin theorem. We will take its equivalent Thevenin resistance and voltage. If we'll be talking about its voltage, it's going to be of 20 in parallel with 20, because 2 volt would be taken as a short circuited. So the value of RTH is 10 ohms, 10 kilo ohms, 10 kilo ohms. And may I know what is supposed to be of VTH? इसको आप बिल्कुल rule out करें, बिल्कुल rule out करें. We had just been focusing over the left hand side. So now it comes in series, and here comes 10 volt. So equivalent circuit is going to be of kind of, here you will be having a resistance of 10 kilo, and here you will be having a voltage of 10 volt. And now this problem becomes much easy. See, 10 kilo and 10 kilo comes in series, they become series resistance R1. RF resistance is nothing but 20. So here it becomes minus. RF is nothing but 20 kilo. Series resistance is nothing but how much? 10 and 10. That becomes 20. And the input voltage has been how much? 1 volt. And yes, together we get the answer as minus 1 volt. Together we get the answer as minus 1 volt. So आप बताएंगे which method had been easier to digest? Obviously, Thevenin theorem. So many of the circuits where the questions are been too complex, better to convert the given circuit into its equivalent Thevenin resistance and voltage, and there we get the output voltage as a minus 1 volt. Minus 1 volt. Has it been clear to all of us? अनंता भाई कौन सा क्लियर है ये बताएं मेरे को. मेरे हिसाब से मैं अगर जाता तो थियोनिन के साथ जाता. और ये प्रॉब्लम थोड़ा सा ट्रिकी इसलिए भी है कि मेनी ऑफ द टाइम्स व्हाट द स्टूडेंट डज, वो 1 वोल्ट यहां लेंगे और 1 वोल्ट के साथ पूरा एनालिसिस करके आउटपुट ले जाएंगे, और आउटपुट उस टाइम पाएगा 20 किलो डिवाइड बाय 10 किलो, एंड दैट बिकम्स -2. चलो टाइमर भी सेट कर देते हैं. ठीक, वी विल सेट द टाइमर एज वेल. We will set the timer as well. And I would request to each one of you, whoever been given the answer, no, take the reference of this page number. This has been 3rd page number, and the next one is going to be the 4th page number. Okay. Okay. Let me take a very well designed question where the value of AOL was non-infinite, and even the circuit also carries a capacitor. Just a minute. Yes, this has been a question, and definitely I'll give you the timer for this given question as well. This has been a question. Just a minute. This has been the 4th question. This problem had been experienced in GATE Electronics year of 2018. NAT type. So let me bring the timer as well. Yes. Anyways, let me read this problem carefully and then I will give you 2 minutes span of time. An op-amp based circuit is implemented as shown below. We had series resistance as 1 kilo, feedback resistance 31 kilo. We had the input voltage as a 1 volt. I need to find the output voltage. In the above circuit, assume that the op-amp to be ideal. The voltage in volt corrected to one decimal place. Sorry, they had been focusing over the voltage across this terminal VA, connected to the negative input of the op-amp as indicated in the figure. Almost same kind of questions which you have already seen. Tell me what is supposed to be the answer over here. Zero hoga ya nahi hoga? Read the problem carefully and tell me what is supposed to be the best most answer which we get for this given question. And this problem has been a part of GATE Electronics year of 2018. The problem was framed by IIT Guwahati. Answers have started coming. As per the AK, answer is 0.5. Anyone else apart from AK? Anyways, take your 2 minutes. Because this question had the weightage of 2 marks. Definitely even you can take 3 minutes as well. No issue. ए पे वोल्टेज निकालना था. चलो निकालो एक बार फटाफट. हाँ अनंत रहेगा, आज मैथ्स की भी क्लास रहेगी मेरी. यस, रखते हैं बीच में एक आध बार. Great, all of us are been getting same answer. 16 volt. How it has been possible? No, not at all. Voltage across terminal A cannot go beyond 1 volt at any cost. See, again the same concept I am going to use. Being an ideal inverting operational amplifier, I expect the output would be minus RF. The RF is nothing but 31 kilo by of R1 into the input voltage, and that is supposed to be of minus 31 volt. As we had already seen, the output voltage cannot go beyond its supply voltages, and that is been at plus 15 and minus 15. So obviously it will be stuck at minus 15. And as the output is being saturated, keep in mind, now the virtual ground theory is no more true. So what we will do the recalculation. We will take the output as minus 15 and then we will take the nodal analysis at point A. So let me do that. So here comes VA, yahan aayega VA, minus of 1 volt divided by of 1 kilo, then comes VA, minus becomes plus, that becomes 15 volt divided by of 31 kilos. 31 kilos is equals to 0. Anyways, my basic understanding is to calculate the value of VA. Yes, we will take its LCM. So here it becomes 31 times of VA minus 31 plus VA plus 15 is equals to 0. Anyways, what happens? 31 VA and VA, they become 32 times of VA. And minus 31 plus 15, how much it is been? Minus of 16. Minus of 16 will go towards right hand side, that would become plus of 16. So the value of VA which we get, it is supposed to be of 16 divided by 32, and that has been 0.5. So in first look, most of the student might have thought of why deliberately they had taken 31, whether they wanted to make this complete calculation too complex. No, my dear friend, deliberately they had taken the RF as 31 so that the 16 and 32, they would be of complete divisible numbers. They would be of complete divisible numbers. Has it been clear to all of us? Ravi and Swami, I used to take mathematics class in daily basis on tab. Definitely few of the very important topics I had been dealing in daily basis. So I would request to all of you better to attend that class as well. So usually I used to have 3 classes. At 8 a.m. I will be live on YouTube as well as Unacademy application both. Then we will be having at 7 a.m. 7 p.m. sorry. And in between somewhere at 1 p.m. I used to be live exclusively on Unacademy platform only. Exclusively on Unacademy platform only. Has it been clear? So you can follow me on Unacademy channel by just searching the educator name as Sonal Kumar Agrawal. Yes, Sonal Kumar Agrawal. चलिए एक आध क्वेश्चन और लेते हैं. हाँ, एक अगला क्वेश्चन लेते हैं. दिस अगेन इज बिन अ प्रॉब्लम. देखिए, नो एडी, whatever the topic I would be teaching, no, definitely you will learn something very great because I teach 5 number of subjects, and personally feeling the best part of my 5 number of subjects is in mathematics. So definitely whichever topic I would be teaching, definitely it would be new to you, a bit new concept you will be learning from me, है ना? So probably I would be having class at 1, 10, 11, 12. Yes, at 1 p.m. we'll be having class, and we had been talking about the calculus and probably probability. So either of the topic would be dealt in today's class. Be present. Be present. So let me take the next question as well. This has been a problem which had been raised in gate electronics. Year of 2016, the problem was framed by IIT Bangalore. Forget about pin diode and all. Just focus over the operational amplifier circuit. That's it. Read the problem carefully and tell me what is supposed to be the best most answer. एक चीज बताएंगे, the way I had been teaching analog, which I include Hindi and both, is it been digestible? So that in future I'll use both, no? So that the students specifically who have been from southern part of our country would be able to digest the fact, because this channel is meant for the communicating the things in Hindi only, but still I'll be managing both, no issue. Then it's fine, no? Then it's fine. बिल्कुल सही है फिर तो. Anyways, here comes the next question. Have a look on this question and tell me what could have been the best most answer. What the problem states: a pin photodiode of responsivity. Forget about pin diode, forget about the responsivity. Just focus over the core and crux values which have been given along with this problem, because in future you can have this kind of the questions even in upcoming 24 or 25 gate examination. Have a look on only and only important part of this circuit and tell me what is supposed to be the output voltage V0. Output voltage V0. आप लोगों को टाइमर चाहिए? चलिए, the timer starts now. Read the problem carefully and tell me what is supposed to be the best answer. हाँ, मेगा में नहीं लेते. यस, but still they had taken, so I can't say anything. But practically we don't do so. We don't do so. और मेगा में लेने के पीछे एक रीजन भी है. I'll give you an example, then only you'll be able to know that. Ananta is saying, sir, as you had suggested earlier, the worth of resistances which we use around the operational amplifier, usually we keep it in kilos. We don't bring it to in range of mega, such that the current across the different limb would become in a range of micros. तो आप यहाँ पर megas में क्यों लिए? Yes, it is required. I'll show you how. I'll show you how. See, have a look on this question. What it says: pin diode of a responsivity of a 0.8 ampere per watt. See, what about the responsivity? Output versus input is being called as a responsivity. Like, if I had been teaching 1 hour on daily basis, how much marks is getting improved by you guys? Let's take by teaching 1 hour, let's take 1 mark is been increasing. So I can say responsivity of you guys is being plus 1 mark per 1 hour taught by Sonal sir. And that is supposed to be of responsivity, you guys' responsibility. And same goes with the pin diode. The pin diode, whenever the radiation falls over the pin diode, what happens? Now it starts flowing across the current. इसके across क्या flow होना चालू होता है? Current. Because the recombination of an electron and hole takes place, and because of the higher excited electron comes back to lower excitation, and thereby the energy is being released, and the energy is being released in the form of electrical current. Did you understand what I'm saying? So more amount of photonic energy will fall over this diode, more amount of electrical current will flow through this diode. Agreed? No? So the power which we had been talking over here, no, this has not been electrical power. This is photonic power. This is a light power. More amount of light intensity will fall over this diode. More amount of current will flow through this. So what had been clearly given? PN diode of a responsivity of 0.8 ampere per watt is connected to the inverting in output of an ideal operational. See, if 10 microwatt of a power is incident, which kind of power? Light power. May you know what has been the responsivity? For each 1 watt, there would be of 0.8 ampere flow of current. If 2 watt of power has been fallen over this diode, the amount of current which will flow through this diode is nothing but 0.8 into 2. Or virtually speaking, this watt and this watt, where it is been? This watt would be, see, so here comes responsivity. Amount of power had been dropped over this diode, and that is being 10 microwatt. Watt and watt goes out, and here it becomes 8 microampere. 8 microampere. Agreed? So amount of current which flows is 8 microampere. No, it is not minus 800. 800 micro. 0.8. And here comes 10 micros. Keep in mind the flow of current through the pin diode is always been from cathode to anode. Why so? Because it is always been operated in a reverse bias. As you can see very well, virtual ground theory has been true, and whereas the positive voltage has been applied across the cathode of this pin diode, it has been operating in a reverse bias. और जैसे reverse bias में recombination start होता है, reverse current starts shooting up. So flow of current which will take place across this diode, no, it is going to be in clockwise direction or upward. Anyways, the student who had been from electronics side, they need not to have second thought about it. Electronics में तो pin diode वगैरह पढ़ना होगा. For the electrical, it is not that necessary. Yes, because in electrical devices is not been a part of it. Devices is not been a part of it. So the amount of current which has been flowing through this terminal or through this limb is nothing but 8 microampere. Being an ideal operational amplifier, it will not any sink amount of current. And here comes 8 micro. Now Ananta had one doubt, sir, why we had been taking the values in megas? Because the amount of current is in micros. Did you really understood what I'm saying? इससे पहले voltage आप लगाते थे, and because of voltage we were getting the current, but now we had been applying a straight away current source, and now I want that current source to be translated in a form of volts, and as the currents are been in range of micros, definitely I want the impedances to be in megas so that their multiplication micros and megas are ruled out. So yes, here comes plus, here comes minus, and here comes 8 volt. Whether the output can go beyond 8 volt? Yes, sir. Definitely it can go. Sorry. Yes, because the range is been plus minus of 15 volts. So may I know what is supposed to be of V naught minus terminal 8 volt. So the best most answer which we get for this given question, it is supposed to be of. Acha, load current pucha hai. Okay, current they had asked. So the current is supposed to be of. Current is supposed to be of. The current will go upside 8 divided by of 10, that is been 0.8 milliampere. कई बच्चे ये पूछेंगे कि सर should I write minus 0.8 or should I write 0 plus 0.8? You can write either of them. Why? Because once you'll see the answer key which was released by IIT, they had taken both range. They had given 0.8 as a correct answer, even they had taken minus 0.8 as also as the correct answer. So many other times this situation also had arisen in the gate examination. What the person would do, they would do the complete calculation, but as the direction of current is not been marked, they won't be able to say whether the answer would be plus or minus. You write either of them, because many other times what they had given range as 0.8 separately and minus 0.8 separately. Sometimes they had also given this as 0.7 to 0.9 and minus 0.9 to minus 0.7. See, और आंसर जो है वो माइक्रोस में लिया हुआ है. माइक्रोस में लिया हुआ है तो what we can do, yes, the 10 could have been multiplied, so the answer is supposed to be of 800. 800, you can write this as a plus or you can write this as a minus. Has it been clear to all of us? This circuit has also been clear or not? No, nobody should say that. No. Generally, okay, you can take that generally, but whenever this kind of the questions are being asked, there are been the process of challenge, and once you'll do the challenge, definitely they'll accept that challenge. What they would do, they won't keep this question towards garbage side. No, they'll give, or they'll split the range in two form, plus as well as minus. Plus as well as minus. ये क्लियर है यहां तक? AD, you are from electrical side or electronic side? Tell me.